Okay, so today we're going to have a look at Dijkstra's algorithm. Now this was invented in 1959 by Edgar Dijkstra, and it's basically just the way of calculating the shortest route through a network. Now it's got 7 steps, so let's have a look at those 7 steps. First step is to label the start vertex as 0. And then we are going to box this number, because the start vertex is essentially hasn't got any distance from where you're starting, because it's where you start from, so that is fixed as 0. All the other boxes that we have will be distances away from that start vertex. Okay, then we're going to label each vertex that is connected to the start vertex with its distance, and when we do that, that's just going to be without a box around it, and that will be its temporary label. And then we're going to box the smallest one of these temporary labels, because that won't be able to change, because that has to be the shortest distance to that point. And then from there we're going to use this vertex to consider all the distances to each of the other points that it's connected to. And if the distance is less, then we will cross out the distance that we already have at that vertex, and if it's not and write down the new one, and if it's not less, then we will just ignore it. And finally we will repeat step 4 until the destination vertex is boxed, put permanent, shall we say. Okay, now the thing here to remember is that we are just going to do this quite logically and rhythmic and carefully throughout the whole of the network. Okay, so let's start by labeling our start. We're going to have A as our start and 0, and we're going to box it. Okay, and then we're going to put our other labels that come out of A. So we're just going to put 4, 8 and 5. Now when we're doing this, it's also best to put where those came from, so that you can keep track of where you're going to, and also when at the end we need to do the shortest path, we can work out what that path is. So this would be 4 and it's come from A, this would be 8 and it's come from A, and this would be 5 and it's come from A. Okay, so we have done what we're up to is step 4. Okay. So this is the shortest one, so we're going to box this value, and then we're going to see what comes out of that one. So from B, we've got connected to both D and E. If we go down to D, we can see this is a distance of 4 plus 3, which is 7, which is smaller than this one, so we put our 7 and where it came from, and cross out our 8 that was there already. And we do our E, and we will have 4 plus 2, 12, which is 16, and that comes from B. Okay, so we're going to box the smallest ones of the ones we've got here, which is the 5, and we're going to see where that goes from here. So if we go from here, we can go 1 up to D. Well, that's now 6. Well, that's smaller than 7, so let's do 6C and cross the 7 one out. And if we go along here, we have 16 from C. Okay. We then look at the 3 we've got, which is the smallest. And that must be the 6. And we work out the distances from this node. So 6 up to here, 6 plus 9 is 15. So that's better than that 16. So let's cross out the 16. We've got 15 from D. 6 plus 10 is 16 from D, and down here 6 plus 4 will be 10 from D, so you can cross out that one. Okay, so we've got our 3. Which one's the smallest? Well, it's the 10, so let's put a box around the 10 and work out from the 10. So 10 up 5 to here will give us 15 from F, so let's cross out that one, and across from here will be 21 from F. Okay, again, go look at which one's the smallest. 21, 15, 15. If we've got 2 we can pick either one, it doesn't matter. So it's up to you. I'm going to pick this one. I'm just going to box this one, but it could have been the other one. As I said, it won't make a difference. So 15 plus 6 makes 21. Well, we've already got 15 here, so we're just going to ignore it. 15 plus 10 will be 25, and it's coming from E. Again, we've got 3. Well, this 15 is the smallest out of those 3. So we're going to box it, and we're going to go from there. So 15 plus 3, well, that'll be 18 from G. So let's cross that one out. Down here will be 20 from G. So let's cross that one out and replace it with 20 from G. And here will be 30 from G. Okay. Look at these 3. The smallest one is this 18. The only root left is down here. Well, that's 32, so that's not any less. So that one is a final one, so that can be boxed, and that's not going to go any further. These 2, this is now the smallest one, and if we go up here, you can see this is 28, so we cross out this one and we get 28 from I. This hasn't got any more ways to go, so that is also boxed. And this is, we've done all 3 roots into this node, so this is also boxed. Okay, so we've done all our nodes, we've completed them. So now all we need to do is write, well, what's our path? Well, start from our endpoint. Well, we know this is at I, so our endpoint is J, and it went to I from here. So let's go down to I. This came from G, so that's going to go to G. G is up here. This came from F. This down here. This came from D. This one came from C. And this one came from A. And so this is our route. We could add the values along this route up to work out the minimum distance that you've actually travelled. And so that will be how you find the shortest path from A to J using Dijkstra's algorithm.